So this video is going to focus on drawing some of these molecules, and we're going to start with their dot structures and then trying to put pieces of a puzzle together is kind of how I describe it. So there's going to be a number of molecules that I'm going to draw out for you, and then I'm going to have you try some on your own. So let's start with our water molecule, H2o. So for this exercise, you are going to need your periodic tables to kind of see, okay, how many valence electrons do you have? And from there. So if I look at where oxygen is going to have 2 in the s orbital and then 4 in the p orbital. So that's a total of 6 valence electrons. So 6 valence electrons, and hydrogen, of course, only has 1 valence electron. So oxygen, I'm going to draw 6 dots around it. So I'll make this a little bigger. So I'm going to do 1 dot on each side, and then I'm going to start to double up. And again, where you double it up doesn't really matter, as long as you have 6 dots around it. But what you're going to see when you start to make these molecules is you do want electrons by themselves, and that is really where you're going to make essentially a covalent bond. So because this electron doesn't have a pair, this electron doesn't have a pair, the hydrogen is going to come in and essentially make a covalent bond. So hydrogen only has 1 dot around it. So what you're going to do is put the dot from hydrogen next to the dot from oxygen, and now you have completed the octet for oxygen. So oxygen now has 8 electrons around it. Hydrogen only makes 1 bond. It does not have any lone pairs or anything on it. That is typical of hydrogen. Hydrogen, because it only has 1 valence electron, because it is in that first column, and that is the one place where hydrogen is in the first column. It has an S1. It has 1 electron there. So therefore, that is, it only makes 1 bond. So let's look at something like CH4. So carbon, when you look up carbon, carbon is right here. You're going to have 2 electrons in the s orbital, and then you're going to have 2 electrons in the p orbital. So you have a total of 4 valence electrons. And again, this is the pattern you see over and over and over again. Hydrogen, of course, has 1 valence electron. So let's put carbon with its 4 valence electrons. So I put 1, 2, 3, 4. And again, that is going to be where it can make a covalent bond. So I have 4 hydrogens attached. So I could put a hydrogen here, I could put a hydrogen here, a hydrogen here, and a hydrogen here. So when we're doing these dot structures, you could also draw a line. So a line in chemistry means 2 electrons, so you could do that as well. And you might find that dots are more helpful in certain circumstances and lines are better. But do realize that anytime you have structures like this, you can do either one. All right, so let's do ammonia Nh3. Okay, so nitrogen, again, find nitrogen on your periodic table. Nitrogen's right next to carbon, so it has 3 electrons in the p orbital and 2 electrons in the s, so it has a total of, excuse me, 5 valence electrons. And hydrogen, again, has 1 valence electron. So again, it feels like we keep doing hydrogen, but there's a reason for that. So nitrogen has 5 valence electrons. So I'm going to do 1, 2, 3, 4, and then I'm going to double up. So instead of doing dots, I could do lines. So I could do a line for my lone pair that I have here, and then I could do a bond with hydrogen off each end. So I have a lone pair on nitrogen, and then I have 3 bonds with hydrogen. Again, you could do it with dots or with lines, or you could do a combo. But realize in all cases, I still am completing the octets. I'm completing those octets, and that's really what you're doing. So see if you could draw, well, let me do beryllium with hydrogen, because beryllium is kind of a weird one. And then I will let you try some on your own. So beryllium is in the second column. It's an alkaline earth metal. It has 2 electrons, 2 valence electrons in the s orbital. So it only has 2 valence electrons. So I can't make it have more valence electrons than it has. So beryllium is kind of an exception, and you will see that we will have some exceptions as we go along the way. Beryllium, it only has 2 dots essentially around it. So it's only going to be able to accommodate 2 more, or to make 2 bonds essentially. So beryllium is quite unique in the fact that it doesn't complete. Okay, so not an octet, and that's okay for beryllium. Okay, so this does occur, and do realize in all of chemistry, you always have some weird exceptions. So I don't have any lone pairs on beryllium. I can't do anything beyond that. All right, so see if you could draw SiF4, PH3, and then BF3. So see if you could do SiF4, PH3, and BF3. So again, pause the video and see if you can draw these three. And then what you will see when you come back to the video are the answers. So what you will see with SiF4, again, Si has 4 valence electrons, so it's going to make 4 bonds with the fluorines, and the fluorines are going to have these lone pairs because fluorine has 7 valence electrons, so fluorine has 7 valence electrons, and silicon has 4 valence electrons. So you kind of put it together. So you're kind of putting pieces of the puzzle together. Phosphorus has 5 valence electrons, so it's going to have a lone pair, and then it's going to have, of course, with hydrogen having 1 valence electron going to complete that. So we've done enough with hydrogen. So boron is unique in the fact that it only has 3 valence electrons. Fluorine has 7. So boron is going to be another, it doesn't complete the octet. And that is unique to boron as well. Again, boron is has 3 valence electrons, 2 in the s orbital and 1 in the p orbital. So it's not going to complete the octet, so it only has 3 bonds around it. So it's also going to be what we call an exception, So this is just an introduction into trying to draw some of these molecules. The next video you're going to see is where it gets a little bit more complex, and there's going to be some steps that you're going to have to do.